We are almost ready to work with Cisco switches, but before that, just a little bit of a history lesson here about hubs, history, and why hubs are history. Got a couple of devices I'm going to introduce you to, a repeater and a hub. Both are considered layer 1 devices, and they were wonderful to have in its time. You're going to see why in just a moment. But of course, times have changed. You're really not going to bump into many hubs out in today's networks, and I don't remember the last time I saw a repeater. It's been quite a while. But let's talk about why we needed these devices to begin with and exactly what they did, because you don't hear of too many layer 1 network devices. When you're listening to a regular radio station, non-satellite in your car, we've all been there. The signal gradually breaks up as you go farther and farther away from the station. Well, that gradual signal weakening, it's called attenuation. And that happens to any electrical signal, and that includes the ones and zeros our networks are busy sending. Now, if we have a couple of hosts that are 175 meters apart and the maximum recommended cable length is 100 meters, you know we're going to push that, right? I mean, it's just a guideline. It's not really a law. Well, you might get away with 101 meters, but 175 meters, that's a pretty big difference. Well, we are going to run into attenuation, and our signal will go from strong to weak to super weak. And that's the kind of thing where repeaters came in handy to begin with, because a repeater's sole job is to take an incoming signal and generate a new and clean, strong copy of that signal so we could avoid those super weak signals. Now, you're going to see symbols in this course for a router and a switch and a hub here in just a moment. There's really no universal symbol for a repeater, so in case you happen to see one on a Cisco exam, I fully expect it to actually be labeled repeater. But with hubs, I'm going to show you a diagram in just a moment that you should be aware that it is a hub, because they might not tell you. Now, before we get to that, of course, what is a hub? Well, a hub is basically a multi-port repeater. Now, some hubs have greater capabilities than others. Some are called smart hubs, while others are just called hubs. But I'm going to show you the issues we run into with hubs. Again, we were still glad to have them, but basically they're multi-port repeaters. And here's that symbol I was talking to you about. If you see this on your exam, job interview, practice exam, wherever, you got to know that's a hub and not be told. So you're looking at one arrow, I should say, with an arrowhead on each end. And so we're looking at a hub here with 4 PCs, and what we have here isn't quite failure to communicate, but it is close, because only one of these hosts can transmit at any given time. And of course, with a hub, we could have 4 hosts, we could have 8 hosts, we could have more, but we're limited to one host transmitting, because if 2 or more hosts connected to a hub send data simultaneously, the data signals will collide, and all data used in the collision is unusable. Using a hub here creates one single collision domain, in that data sent by any host can collide with data sent by any other host. You're going to be introduced to the phrases collision domain and broadcast domain in this section. You're going to see the effects that hubs have on them, bridges have on them, and switches have on them, and you got to be crystal clear for that, especially for the CCENT exam. If you're taking the 2 exam path, you've got to be absolutely crystal clear on what these devices do with collision domains and broadcast domains. So we know that a hub, we end up with one big collision domain, and there it is. Now, to prevent those collisions from happening, or happening as often as they would otherwise, we developed a little something called Carrier Sense Multiple Access with Collision Detection, which fortunately we call CSMA-CD. And here is that overall process. Before sending data, a host is going to check to see if anyone else is already sending data, and this is called listening to the wire. Now, if that check reveals another host is sending data, the host is going to back off for a few milliseconds before it listens to the wire again. And if no one's sending data, then the host goes ahead and sends its data. Now, this could be, and of course, the more hosts you have on the hub, the greater the chance of this happening. If 2 PCs happen to send data at the exact same time after listening to the wire, the voltage on the wire itself is going to change, and that signals to the host, hey, that data you just sent, it collided with someone else's. And in that case, the PCs, or the host that sent the data, will generate what we call a jam signal. And what you're doing, it's basically yelling to everybody else on that shared segment, hey, don't send anything because we've had a collision and we're cleaning up from it, basically. The PCs that sent the data involved in that collision then invoke what we call a back-off timer, and it's pretty much just what it sounds like. because when each host's random back-off timer expires, they begin the entire process again by listening to the wire. We're always coming back to listening to the wire with CSMACD. Now, the back-off timer is set to milliseconds, and it's a totally random value. So the odds of another collision involving these hosts and that data is highly unlikely. So, we were happy to have this again in the day, CSMACD, and of course it's still around, but it does introduce delays we'd rather not have. As soon as you hear the back-off timers and data colliding with each other, we really don't want that. And especially today, because the high level of delay sensitivity we have with voice and video traffic, I mean, those two traffic types are really unforgiving as far as delays go. And believe it or not, there's actually another major issue with hubs and repeaters we have to be aware of, and that is that we also end up with one large broadcast domain when we are using a hub. And a repeater would be the same thing, but we'd only have two devices connected to it. Every single time that any host connected to this hub sends a broadcast, which is basically a message meant for everyone, every other host on that hub is going to get a copy of that broadcast. So, you might think, well, so what? First off, if it's a broadcast, don't I want everybody else to get it? Generally speaking, not every device that can receive that broadcast needs that broadcast. And as network admins, we are very interested in preventing that unnecessary spreading or propagation of a broadcast throughout the network, because I really want to drive this point home with you right now. It's a great place to do it near the beginning of the course. Everything we do on a Cisco router or switch has a cost in one form or another, whether it be time, whether it's a hit to the processor, a little more work, whether it's using bandwidth that we really don't need to use, whether it's unpacking packets that the router shouldn't have received in the first place. And we're going to run into different scenarios with that, but that's why we're a little wary about these broadcasts. Because when we have one big broadcast domain, there's no way to limit what we call the scope of the broadcast. Maybe we don't want this broadcast being spread through our entire network. So that is a problem that hubs bring, and unfortunately for us, do not solve. Because let's say that we had 64 hosts attached to a hub. If one host sends a broadcast, all the other 63 hosts are going to get a copy of the broadcast. A copy is never sent back out the same port that it came in on. So if only 3 of those 63 actually need the contents of the broadcast, we're running into all kinds of unnecessary costs, because then the hub is creating and sending 60 unnecessary copies of that broadcast. And every host still has to unpack the incoming broadcast. It still has to inspect the contents of it and then say, oh wait, I don't need this, and then throws it away. And we're also sucking up bandwidth really unnecessarily with those 60 unneeded broadcasts, because that can lead to what we call a broadcast storm. The levels of broadcast keep rising and rising and rising in your network, and sooner or later it does start impacting the overall performance of your network. So again, we want to limit the scope of the broadcast as much as we can to prevent their unnecessary spread. We still have to let them go where they're going, but as we'll see, we'll learn some tactics throughout this course really just to prevent unnecessary broadcasts from going out. So again, our hubs and repeaters, they helped us out in some ways. They helped us out with the attenuation issue, but they leave us with two major problems. You end up with one big collision domain, and you end up with one big broadcast domain. Then came the bridge. Ta-da! And we will talk about the bridge at the beginning of the very next video.